We are going to continue our theme of looking at many different representations of linear equations. So what we need to know is that words, equations, tables, and graphs can all be used to represent linear relationships. If we notice, let's look specifically at the slope. All right, it's easy to identify the slope in this equation. We see it as the coefficient. Okay, so it's the coefficient of x. And that's how we identify the slope in the equation. What about over here? In the word problem, we see 12 miles per second. The key is this word per. We know that it is a rate, okay? And that's how we can identify the slope in a word problem. How do we identify the slope in a table? We do change in y over change in x. And we notice that our change in y is 12. Our change in x is 1. So our slope in this equation is 12. What about in a graph? Well, same thing. We're going to do rise over run, and we end up with a similar thing. Our rise being 12, our run being 1. So in this case, m equals 12. So notice, it doesn't matter what kind of representation we have, whether it's a word problem, whether it's an equation, whether it's a table, whether it's a graph, we need to be able to identify the slope or the rate of change and be able to use that to write equations or interpret a solution. Let's take a look at this one here. Example 5 in your book says that Chloe jumps rope in competitions. Her average rate is 225 jumps per minute. So we're to come up with an equation for the number of jumps in any number of minutes. So I want to know, let's say J equals jumps, okay? And let's say that, we'll say M is going to equal minutes. So basically what they're saying is, if I give you a number of minutes, I want to know how many jumps she has done in that number of minutes, okay? So how can we do that? Well, we know based on the word problem, it says she does 225 jumps per minute. So that gives it away right there. All right, this is a rate. And when we know the rate, that tells us what our slope is. So our slope or our rate is 225. So my equation is going to be J, the number of jumps, equals the 225, which is our rate, times the number of minutes. So does that make sense? If I say after 10 minutes, how much has she jumped, I should be able to just substitute in 10 for the number of minutes and be able to know that she has jumped 2,250 jumps in 10 minutes. So that does work, okay? So that's great. We have able to come up with our equation, J equals 225M, okay? Now we've got to take that equation, and they're asking us in the next example to make a graph out of it, okay? So, and a table. So the number of minutes, we'll just say 1, 2, 3, 4, and 5. Okay, we want to know how many times she's jumped. So what we're going to do for here is we're going to multiply 225 times 1, 225 times 2, 225 times 3, etc., etc. And what we'll get is, this will be pretty easy, 225. When we multiply it by 2, we get 450. 3 is 675. 225 times 4 is going to be 900. And times 5 is going to be 1,125. So we were able to make a table based on using this equation, right? So it's almost like an input-output table. I put 1 in to the equation, all right? So I put the number 1 in for M, and what I get out is the number of jumps. Okay, now what about graphing that? Well, now we can take these as our coordinate pairs. So 1, 2, 25 would be one of our coordinate pairs. Okay, and we're simply going to graph these as best we can along here. So 1 is going to be a little over 200, 225, something like that in that neighborhood. And 2 is going to be 450. All right, so we're looking at, I don't know, something maybe in this neighborhood right here. Okay, and then once we have these lines plotted, we simply draw our line, and we're able to make a graph representation of the number of jumps that Chloe does per minute. Okay? So once again, let's go over this. We came up with an equation by finding the rate and using the variables provided for us. Once we found that equation, we used it to create a table, putting the number of minutes in and getting out the number of jumps. And once we created the table and came up with coordinate pairs, we plotted those points on a graph and were able to draw a line representing the number of jumps she gets per minute. All right, I hope this has been helpful. Go ahead and try the got it problem at the bottom of page 271.